Okay, so I think we got this right. So if you have a triangle, an equilateral triangle with side length s, then the area is s squared times the square root of 3 over 4.
Yes.
And that's what we're finding here. At step 1, we just had one triangle with side length 9. We got 9 squared, square root of 3 over 4. Then we were adding on 3 of these triangles whose side length was 3. So 3 times 9 root 3 over 4. Then we had 12 adding on, and they were side length 1. And then we were adding on 48 times 1/9 times root 3 over 4. Okay.
Yeah, so root 3 over 36.
Yeah, or however, like each time we had a root 3 over 4, so we were at 81, then 3 times 9.
7.
And then it was 12 times 1. And then it was 48. And this might be going off camera. I'll write it down here. 48 times 1/9. And then we always had the root 3 over 4.
Yes.
Okay, so do we see any pattern emerging here?
Well, so for the larger coefficient of the side length, this always goes from 81 to 9 to 1 to 1/9. So that is being divided by 9 every step.
Okay, yeah, that's great.
And then the amount of triangles we add on goes from, let's see, 1 to 3 to 12 to 48. So if we say we sort of start at the second step,
Okay.
we're multiplying the amount of triangles we add by 4 every time.
Okay. All right. So we seem to be, the area we're adding on seems to be divided by 9 every time. Now, why is that?
That's just because...
Sorry, not the area we're adding on, the area of the individual triangles we're adding on. That's what I meant.
Because the base and the height both get divided by 3.
Okay. All right, so we can understand that divisibility by 9. Why is the number of triangles we're adding on each time seeming to be multiplied by 4?
So you can imagine for the next step, you can look at each one of these segments, like the smallest triangle you have, and then the straight lines next to that, and you can add 4 triangles to that. 1, 2, 3, 4.
Okay.
And yeah, so you basically multiplying the number of triangles by 4.
Okay, great. So it does seem like we're getting an interesting pattern here. So let's see if we can maybe factor out the square root of 3 over 4. That always seems to be there.
Yep.
And we get 81. But the pattern doesn't really, of multiplying by 4 really only starts later, but
yes.
that's fine. So we get the 3 times 9. Then we get plus 12 times 1.
And then 48 times 1/9.
Plus 48 times 1/9. Okay, so what do we think the next one of these is going to be?
So probably, let's see, 192 times 1/27th. Because we're multiplying 48 by 4 and a 9th, or 1 over 81.
Okay.
So we're multiplying a 9th by a 9th.
Alright, so 192 times 27, and then what might the next one be?
192 times 4.
Tell you what, I will even do that on the calculator so we don't make a mistake. 4 times 192. That's 768.
Times 243. Or 1 over 243.
Alright, 27 times 9, I think, is 1 over 243. Yeah. Okay, so now maybe we can find a way to simplify this a little bit, especially if we just take out the first one and just leave the 81 on its own.
Okay.
All right, so let's go to the next video and maybe we can simplify this.